So we're going to write down here the times, and then we're going to measure them. So time 1 and time 2. And we will see whether these two numbers are the same within the uncertainty of our measurements. Here is the air track. Have to turn on the airflow. Oh, let me tell, for those of you, for the parents in my audience who haven't seen this one, this is a marvelous device. It is a track which is well constructed so that these cars fit beautifully on this V-shaped track. And then we blow air out of this track, which lifts these cars up so that they float. And so we can move them in horizontal direction with extremely little friction. There is no metal touching metal. The only friction you have is the air drag. That you can never avoid. When you go through the air with a car, there is wind, the same wind that you feel when you drive your bicycle. But it's very little, and that's why these experiments are done on these air tracks. These are not cheap, by the way, these air tracks. They're very expensive. Well, you pay $25,000 tuition, so you might as well get something for it, right? So I hope that these timers are on. They are. And now we have here one car. And notice how frictionless it goes when I touch it. It's very nice, almost frictionless. And here we have another one. And they have equal mass to within 1 gram. And there is a spring between them. Some of you may be able to see it. And I'm going to attach now that string to hold them together. And so I put potential energy in the spring by pushing them together. And they're lined up now here. They have no momentum. The timer is not on. Has to be reset. Thank you. They're now both 0. Yeah, you sure? Okay. So now I'm going to burn off that wire. The momentum of each one of those cars will change. One will go in this direction, the other one in this direction. Kinetic energy will increase. That's the potential energy from the spring. But the momentum of the system as a whole, after I burn the wire, will remain 0. Ready for this? Make me happy. What do you see? You're going to make me unhappy? I better walk around. I can't wait. 220. Ah, fantastic! Absolutely fantastic. 223, 219 milliseconds. That is well within the uncertainties. What was the number? 219? 219 milliseconds and 223 milliseconds. If I repeat the experiment and I make the string shorter, I will get different times. I can never predict the times, because if I make the spring more squeezed, then obviously I will have more potential energy, and so the speeds of the cars will be higher. But the times will be the same within the uncertainty of the measurements. So I can never predict the time.